The date was February 20th, 1943, and the air north of Kasserine Pass, Tunisia, was thick with the scent of diesel and cordite. The battle report that followed could never fully capture the bewildered shock on the faces of the veteran German tank commanders. They were the heirs to the Blitzkrieg, masters of tank warfare. Yet what they witnessed that morning defied everything Wehrmacht doctrine said was possible without visual signals. Through the choking dust and smoke of the North African battlefield, 5 American Sherman tanks were executing a ballet of coordinated destruction. These tanks were separated by broken, undulating terrain with no line of sight between them, yet they moved as a single, terrifying organism. They converged on the German positions with a timing that seemed to the Panzertruppen nothing short of supernatural. In the minds of the German crewmen, this level of synchronization was impossible. Tank warfare, by their doctrine, demanded visual signals, flags waving frantically from commanders' hatches, flares arcing high over the battlefield, or vulnerable dispatch riders racing between vehicles to relay orders. But here, in the heart of the fight, there were no flags, no flares, no dispatch riders. Yet each American tank crew knew exactly where their comrades were positioned, seamlessly covering blind spots the others couldn't see. The question was immediate, stark, and terrifying. How? What technology or training allowed an American platoon to move with such terrifying, unified precision? A precision that should have required absolute visibility. The answer, unknown to the Panzertruppen, was the most decisive technological advantage of the war, concealed not in steel but in the air itself. The truth, a fact unknown to the German tank commanders who fought so bravely, was that the most decisive technological advantage of World War II was not the German 88mm gun, nor the thick armor of the Panther or Tiger. Instead, the real revolution lay in the invisible electromagnetic waves that seamlessly connected every American tank crew. While the Wehrmacht fixated on platform superiority, bigger guns and thicker steel, the Americans had achieved something far more profound: information dominance. The humble M4 Sherman was not simply an adequate medium tank. It was transformed by 181 pounds of radio equipment into a crucial node in history's first battlefield network. This technological edge, born on Detroit's assembly lines, meant that the American forces were never just fighting isolated battles. They were fighting as a unified, connected mind. To understand the scale of the American advantage, we must first look inside the cockpit of a German Panzer IV, a tank widely respected for its formidable 75mm gun. This superiority was crippled by the FUG-5, the standard radio set of the Wehrmacht. While technically considered state-of-the-art by the standards of the 1930s, the FUG-5 was fundamentally flawed for mobile warfare. It operated using amplitude modulation, AM, a system catastrophically vulnerable to battlefield noise. Imagine a German commander attempting to issue orders. Every time the engine roared, the tracks rattled, or a nearby gun fired, the radio was overwhelmed by a tidal wave of static and interference. This 10-watt German transmitter struggled to penetrate more than a few hundred meters when tanks were moving, reducing a platoon's effective range to little more than visual sight lines. But the most crippling design flaw was not the noise, it was the deployment. For the sake of efficiency, only 1 or 2 tanks in a 5-vehicle platoon were equipped with a full transceiver, capable of both transmitting and receiving. The remaining vehicles carried only receivers. This meant that the majority of German tank crews, positioned on the flanks or rear, were unable to report what they saw or call for help. They could listen to orders, but they could not contribute to the shared awareness of the battle. Their command structure was a rigid pyramid built on silent, isolated nodes, creating a catastrophic vulnerability whenever the command tank was lost. The shift in power began far from the battlefield, on July 22, 1941, when the United States Army standardized the Signal Corps radio sets ARRI SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces were preoccupied with the Soviet Union, American engineers at Galvin Manufacturing Company, which would later become known globally as Motorola, were perfecting the technology that would render German systems instantly obsolete. This was the American Revolution in communications, championed by two key figures: Daniel E. Noble, who first conceived the application of frequency modulation technology in military vehicles, and Henryk Magnowski, the principal RF engineer who solved the colossal technical challenge of installing sophisticated electronics in the harsh, vibrating environment of a tank. Their creation was the SCR-508 family, a system that provided crystal-controlled precision. This stability was critical for maintaining alignment across the 10 preset channels. Most importantly, the BC604 transmitter generated 25 watts of power, making it 2.5 times more powerful than the German FUG-5's 10-watt output. This 181-pound system didn't just equip a tank, it transformed the vehicle, giving every American crew the power to project their voice and their situational awareness across the entire battle space. The entire disparity in battlefield communications hinged on one single scientific breakthrough, pioneered by American inventor Edwin Armstrong: frequency modulation. The German FUG-5 was tethered to the past with amplitude modulation. The fundamental problem with AM is that it transmits information by changing the height or amplitude of the radio wave. Unfortunately, every electrical discharge, from a tank's spark plugs to the whine of the engine to the grinding of steel tracks, also manifests as a change in amplitude. This meant that the German commander's voice was constantly being masked by a blizzard of battlefield noise and static. FM, however, ignores amplitude and transmits information by changing the frequency of the wave. Since battlefield noise is almost entirely an amplitude phenomenon, the FM receiver can simply discard the noise and capture the pure frequency-modulated signal. The result was a dramatic difference. While German crews struggled to hear their own company leaders through a high-pitched din, the American SCR-508 delivered clear voice communication even during artillery barrages. The technical specifications bear this out. The German FUG-5 operated in the higher, more rigid range of 27.0 to 33.3 MHz. The American SCR-508 utilized the slightly lower range of 20.0 to 27.9 MHz, which offered a balance of range and clarity. This scientific difference meant that the American network was stable and reliable under combat stress, while the German system was functionally silent precisely when the need for communication was most desperate. The science of silence became the silent key to victory. The difference between the two radio systems was not merely technical, it was a fundamental difference in battlefield philosophy. Because the Americans achieved 100% radio deployment, meaning that every single Sherman could transmit and receive, they unlocked a fluidity of command the Germans could only dream of.
The key was the dual receiver system built into the SCR-508. The main component, the BC603 receiver, allowed the tank commander to monitor both the platoon command net and the company command net simultaneously. This meant that a platoon could be executing a local maneuver while the company commander was talking to a distant battery of self-propelled artillery, and every individual tank commander was privy to both conversations. Every Sherman became, by default, a command vehicle, capable of stepping into the leadership role instantly if the lead tank was disabled. Contrast this with the rigid German hierarchy. Their command tanks were often betrayed by their multiple radio antennas, making them prime targets for American gunners. Once that single command tank was destroyed, the entire platoon lost coordination. The silent, receiving-only tanks were left isolated, unable to adapt to the sudden shift in battle, often freezing in place or retreating in confusion. The SCR-508 system turned the American platoon into a self-healing, decentralized network. The FUG-5 left the German platoon as a brittle, centrally controlled glass cannon. The SCR-508 system's first major trial by fire occurred in November 1942, during Operation Torch, the Allied invasion of North Africa. The 2nd Armored Division, equipped with the new radio sets, immediately demonstrated their tactical value in the sprawling, decentralized battlefields of the desert. While the initial encounters were often costly for the inexperienced American forces, particularly at Kasserine Pass in February 1943, the seeds of the new doctrine were firmly planted. Despite the overall tactical German victory at Kasserine, the battle revealed unexpected American capabilities that stunned Wehrmacht observers. German officers noted with alarm that American units, though often forced to retreat, were able to reform and coordinate counterattacks with exceptional speed. American tank companies frequently maintained voice communication across 50 miles of battlefield, relaying information about German flanking movements and artillery concentrations back to division headquarters almost instantly. The Germans, relying on their limited Fug-5 range and hierarchical command structure, had never encountered such a resilient, interconnected opponent. Kasserine Pass was a brutal lesson in defeat, but it was also the first proof point for the core thesis. Even in retreat, the American forces possessed an unseen, pervasive network that allowed them to manage chaos and sustain a coherent defense, something the isolated German tank crews simply could not match. This new American capability was immediately apparent on the battlefield, yet it was the subject of one of the greatest intelligence failures of the war. German signals intelligence units, tasked with monitoring American communications, noted the exceptional clarity and coordination of the enemy forces with alarm. They intercepted the crystal-clear voice traffic that seemed unaffected by the combat environment. But here, their short-sightedness became fatal. Having convinced themselves of their own technological superiority, the German High Command attributed this American efficiency not to superior equipment, but to extensive training in rigid communication procedures. They fundamentally completely missed the technological advantage of frequency modulation and the 100% deployment rate. They assumed the Americans were simply disciplined, not technologically advanced. Consequently, the Wehrmacht did not change its tactics. They continued the costly, misguided strategy of prioritizing the destruction of easily identifiable command tanks, a strategy that became increasingly irrelevant as every Sherman proved capable of assuming command functions. The Germans failed to realize that their tactical enemy was not a tank or a platoon, but a high-speed, adaptive network. After the initial North African engagement, the war moved into the unforgiving terrain of the Italian peninsula, starting in September 1943. Here, the advantage of the SCR-508 only grew more pronounced. Logically, mountainous topography, with its steep inclines, deep valleys, and constant visual obstructions, should have negated radio use entirely. Metal-bodied tanks attempting to communicate through rock and shadow should have found their signals degraded to uselessness. Yet, this challenging environment actually played into the strengths of the American Frequency Modulation system. The German AM Fug-5 radios were fatally susceptible to multi-path interference. Radio waves bouncing off the sheer cliff faces and terrain features would arrive at the receiver at slightly different times, creating a garbled mess of echo and static. In the narrow mountain valleys, German radios often failed completely, leaving entire companies blind and deaf, forced to rely on visual observation in terrain where visual contact was impossible. The American FM radios, however, proved remarkably resilient. The crystal-controlled precision of the SCR-508 helped it filter out this interference, allowing American tanks to coordinate complex movements through mountain passes and around hidden German defensive positions. American commanders could call in immediate fire support or report an enemy breakthrough across distances that were utterly silent on the German net. The American forces could therefore move with confidence and coordination in terrain that was specifically designed to fragment and isolate an attacker, ensuring that even the most difficult geography could not break the network. As American forces hit the treacherous bocage country of Normandy, a critical flaw in the SCR-508 system was brutally exposed, demonstrating that even advanced technology has its limits. The problem was one of frequency. The tank's powerful SCR-508 radios could not communicate with the infantry standard SCR-300 walkie-talkie, which operated on different frequencies. This communication gap proved deadly. Infantry and armor unable to coordinate their movements through the dense hedgerows were isolated, leading to unnecessary losses and slowing the advance to a crawl. The network was strong, but it didn't yet include all the necessary players. But the American system's ultimate advantage was its adaptability. Engineers and mechanics on the ground quickly devised a simple, elegant solution. They took the infantry's EE-8 field telephone, a basic magneto-crank device, and mounted it externally in a welded ammunition box on the Sherman's rear deck. This field phone was then wired directly into the tank's internal intercom system. Now a squad leader remaining safely outside the tank could simply plug in and speak directly to the tank commander without risking his life or relying on hand signals. This simple, field-expedient modification revolutionized tank infantry cooperation and was rapidly disseminated across the front, making the full coordination seen during Operation Cobra possible just weeks later. The network had found its crucial missing link. The accumulated technological advantage of the SCR-508 reached its devastating zenith during Operation Cobra in July 1944. This was the moment the network was truly unleashed. The 2nd Armored Division, now operating seamlessly after adopting the hedgerow communication fix, coordinated the movements of over 200 Sherman tanks and supporting vehicles via radio, achieving unprecedented battlefield control and shattering the German lines near Saint-Lô. The German defenders from the elite Panzer Lehr Division were paralyzed by the speed and fluidity of the American attack. Their commanders, still trapped in the Fug 5 static-filled vacuum, were unable to react in time, leading to astonished reports that the Americans possessed supernatural awareness of their movements. Crucially, the instantaneous coordination wasn't just tank-to-tank. Artillery strikes, which traditionally required a slow multi-stage communication process, were now being coordinated directly through tank radios. American forward observations riding with the armor could call in fire support that arrived within minutes of target identification. The network allowed the Americans to turn their immense firepower superiority in both armor and artillery into overwhelming, concentrated combat power, transforming a technological edge into a decisive strategic breakthrough. Operation Cobra was the ultimate confirmation. Connected forces win. The communication gap was not a simple oversight. It was a profound failure of execution that betrayed the very doctrine that Germany invented. The irony is inescapable. Heinz Guderian, the revolutionary architect of Blitzkrieg, had insisted since the 1920s that reliable radio equipment was the foundational principle of armored warfare. His entire devastating doctrine required fast, flexible, and fully connected units. Guderian knew, perhaps better than anyone, that speed and mass rely on communication. Yet, by 1943, the German war machine had fundamentally failed its own pioneer. While the United States industrialized the SCR-508 for mass production, German industry fell catastrophically short. Despite building approximately 12,000 medium and heavy tanks by 1943, German manufacturers managed to produce only around 6,000 Fug transceivers. This meant that the majority of their formidable panzers, the Tigers and Panthers, lacked the ability to transmit orders or intelligence, turning them into isolated guns on tracks. Guderian's brilliant vision of a coordinated armored spearhead was crippled by logistics and technological conservatism. The defeat was, in a sense, self-inflicted, a predictable consequence of prioritizing the visible power of the gun over the invisible power of the network. The true secret to the SCR-508's dominance wasn't merely its technical specifications. It was the sheer industrial power of the United States and the relentless efficiency of the private sector. While Germany struggled to convert its technical superiority into mass-produced equipment, Galvin Manufacturing, a company that had been focused on producing car radios, retooled its entire operation to deliver the complex SCR-508 system. This was no simple piece of equipment. Each radio set required extreme precision, built from a staggering bill of materials that included 2,748 total components, such as 474 capacitors and 385 resistors. To produce such complex, robust electronics on a massive scale was a monumental engineering feat. Yet, the American industrial machine delivered a miracle.
The production statistics speak volumes. The year 1944 alone saw the output of 24,000 SCR-508 radio sets. Total wartime production for the family of radios soared to over 50,000 units. This colossal output ensured the critical strategic goal: 100% deployment. Every single one of the 49,324 Sherman tanks manufactured received this advanced communication package. In stark contrast to the German system, where tanks were selectively equipped, the American strategy ensured that every vehicle, from the lead command tank to the last tank in the column, was a fully functional node in the network. The victory of connection was won not just on the battlefield, but months earlier on the assembly lines of Chicago. The ultimate shocking proof of the network's superiority came in September 1944 at the Battle of Arracourt, France.
This was the moment where technical specifications were brutally rendered obsolete. The American 4th Armored Division operating Sherman tanks went head-to-head against superior German forces, fielding the formidable Panther tanks. The Germans had every advantage. The Panther's sloped armor was nearly impenetrable to the Sherman's 75mm gun, and the Panther's 75mm high-velocity cannon could destroy a Sherman from 2 kilometers away. Yet, coordination was decisive. The American radio network allowed individual Shermans that had spotted a Panther to instantly report the position, movement, and bearing of the enemy. That intelligence didn't stop at the nearest company commander. It was immediately routed to all surrounding units and, most importantly, to the devastating American artillery batteries. These murder-on-call artillery strikes, coordinated in real time by the FM network, arrived within moments, forcing the isolated and confused Panthers to abandon their strong positions or face annihilation. The final result was a stunning humiliation for the German forces. 281 German armored vehicles destroyed versus just 41 Shermans lost. This 7-to-1 kill ratio was a statistical anomaly that defied every technical specification of the tanks themselves, proving once and for all that a connected, organized, and informed network would always defeat isolated, superior platforms. As the Allied armies surged across France and pushed towards the Rhine in 1945, the communication gap defined the final strategic movements of the war. The swift, opportunistic capture of the Remagen Bridge demonstrated the devastating speed of American command and control. Radio reports from the leading armor elements reached division headquarters almost instantly, allowing American forces to commit reserve divisions to the bridgehead within hours, before the Germans could effectively organize a counterattack or demolition. Conversely, the German high command remained sluggish, unable to verify reports or coordinate the necessary defenses across their decimated forces. This inability to react in real time led directly to the climactic encirclement of the Ruhr Pocket. The American ability to rapidly shift entire divisions based on real-time intelligence allowed them to trap an astronomical 325,000 German troops. Field Marshal Walter Model, commander of the trapped Army Group B, sent his final, hopeless messages that serve as the epitaph for the German communication failure. No contact with adjacent units, coordination impossible. The German war machine was not merely running out of men and fuel, it had become an uncoordinated collection of isolated, deaf components. The silence of their radios provided the Americans with the ultimate, final advantage. The ultimate consequence of the communication gap was measured not in destroyed metal, but in human psychology. American tank crews, constantly hearing the clear voices of their comrades and commanders, fought with the unshakable conviction that they were never alone. Every threat was shared instantly, every success was supported immediately. This psychological resilience, the comfort of the network, reduced panic and boosted aggressive confidence. Conversely, the German crews experienced a profound, terrifying isolation. When the command tank was hit or the noise became too loud, they were cut off, fighting as isolated individuals in a fog of war that the enemy had already pierced. Their failure was structural. They were superior platforms fighting like scattered, unconnected parts. This tragic reality was purportedly summed up by Field Marshal Wilhelm Keitel during Germany's surrender. "We knew how to build better tanks, but you knew how to make them work together." The American system delivered confidence and cohesion. The German system delivered fear and fragmentation. The war's end provided the definitive, uncontested analysis of the communication gap. Official U.S. Army intelligence reports studying captured equipment and interviewing German prisoners concluded unequivocally that German signal and electronic equipment was approximately 5 years behind American systems. This finding validated the battlefield experience and corrected the faulty German assumptions of their own superiority. The lessons learned by German troops facing the SCR-508 didn't vanish with the war's end. They became the bedrock of modern military doctrine. The German military itself, the Bundeswehr, codified the historical lesson into its training manuals, stating that the defeat of superior German tanks with inferior American vehicles with better radios teaches that information dominance outweighs platform superiority. The principle is eternal.
Better information is a force multiplier greater than any increase in armor or armament. This historical validation was proven again in the modern age. The Gulf War 1991 and the Iraq War 2003 served as live fire demonstrations of network-centric warfare. American forces, linked by advanced digital communication systems, satellite feeds, and GPS, moved with a speed and accuracy that shocked their opponents. Just as the Sherman's radio rendered the Panther's armor irrelevant, the digital network of the 21st century made massed, uncoordinated armies obsolete. The principle that began with a simple FM radio in 1943 remains the key to modern conflict. Network-centric warfare defeats platform-centric warfare. The invisible advantage is now the only advantage. This is the ultimate lesson of the SCR-508. The M4 Sherman was never truly a medium tank fighting alone. The radio transformed it into the component of a weapons system that included every other American tank, every artillery piece, and every command post on the battlefield. This network was the decisive advantage.
We can conclude that the electromagnetic waves carried by SCR-508 radios proved more powerful than the armor-piercing rounds fired by German 88mm guns. The Germans built a superior platform, but the Americans built a superior system. The ability to coordinate, to share information instantly, and to fight as a unified adaptive force determined victory more surely than any visible superiority in armor or armament. This invisible advantage changed warfare forever. Section 20. The Invisible Advantage. Approximately 150 words. Summary. Deliver the ultimate takeaway. The transformation occurred largely invisible to German forces. 81. They saw American tactical superiority but didn't recognize its technological foundation until far too late. 82. The principle established, connection equals survival and isolation equals defeat. Final call to action and concluding thought. Psychological angle, mic drop, and sense of awe leaves the viewer with a profound final thought that changes their perception of WWII history. The invisible advantage. The tragedy for the German forces was that this defining technological transformation occurred largely invisible to German forces. They were confounded by American tactical superiority, yet they failed to recognize its technological foundation until far too late. By the time German commanders understood that every Sherman tank possessed the communication capabilities that most German tanks tragically lacked, the war was effectively decided. The SCR-508 radio did not just help win World War II, it established a universal military principle for all conflicts that followed. That principle is simple, profound, and undeniable, and it is the key to understanding the war's final outcome. Connection equals survival, and isolation equals defeat. This is the secret the German troops never knew, and it is the single most important lesson we can draw from the true history of the Sherman tank.